Okay, this question, maximum subarray, is very straightforward. Given integer array nums, find the contiguous subarray, which cannot be an empty array, which has the largest sum and return its sum. Without the background knowledge, this question can be a little bit difficult. Thus, I give it a median level of difficulty rating. So now let's see what is the background knowledge required. First of all, it requires understanding of dynamic programming. Dynamic programming is very straightforward. It mainly is about breaking down a main problem into smaller subproblems recursively. Then you solve the subproblems, and finally you leverage the optimal solution from the subproblem to solve the main problem. For example, given the question, what is the sum of 1 plus 2 plus 3 plus 4 up to 10 and then plus 11? Then you solve the subproblem first. What's the sum of 1 plus 2 until 10? And the answer, as you know, is 55. Thus, the answer to the main problem will be simply 55 plus 11 without the redundancy to recompute the 1 plus 2 up to 10 part. And the other aspect you need to know first is Kadenas algorithm. This algorithm is specifically useful for solving the maximum subarray problem with time complexity O(n). For example, given its main problem minus 2 to 4, we have two questions each time. Where to start? Let's say we start iteratively from the zeros position and so on, and then where to end. Then for each starting position, we scan through all the remaining array for each possible ending position. And that gives us a brute force solution. So before we can appreciate Kadenas algorithm, let's understand the brute force and its limitations so we can appreciate Kadenas algorithm more. So the brute force solution has a O(n) squared time complexity, as you can see here, the double for loop. But given the O(n) squared time complexity, it involves a lot of redundancy. In contrast, dynamic programming and Kadenas algorithm use optimal sub-solutions from previous operations without repeating a lot of these plus equal operations over and over again. Now we look at Kadenas algorithm in more detail. So given the main problem, we want to break it down to the subproblem with only two numbers at a time. And our question is, what is the best subarray running sum so far? And we look at the minus 2. And we ask ourselves the question, is it worth keeping? And the answer here is that since it's not positive, minus 2 is not positive, it will not add a value to the follow-up additions. Therefore, we discard it and restart with 1, with the current number 1 as our running sum. And then we can move on to the next number in the main problem. Here we look at minus 3, and we break it down to only two numbers again in the subproblem. We ask ourselves again, what is the best subarray running sum so far? We know it's 1, and this 1 is worth keeping because it will add positive value to the follow-up addition. Therefore, we keep it and then add with the current number minus 3. Now we can repeat this process recursively. Look at minus 2, which is 1 minus 3 equal minus 2. We discard it since it's negative and not positive. Next, we have 4, we keep it. We have 4 minus 1 is 3, we keep it. We have 3 plus 2, 5, we keep 5. We have 5 plus 1, 6, we keep 6. We'll later find out that this number 6 is our global maximum subarray sum, and we need to be able to track it. Let's continue. So 6 minus 5 is 1, and finally 1 plus 4 equals 5, and that's it. With all the background knowledge introduced, we are now ready to write the code. But first of all, we look at this brute force with time complexity O(n) squared, and we run it to see how it works. So it's running and it's judging, and let's see. And the problem with the brute force is that it has n squared time complexity, so it will give us a time limit exceeded error here. To improve the time complexity, we're going to use dynamic programming and Kadane algorithm here. So first of all, we'll have a running sum. It's a local sum, and we initialize it to negative infinity, and a global maximum sum. Also, we initialize it to negative infinity, and then with each number in the nums array, we do it recursively. We want to see if the current running sum, let's say the current running sum, if the current running sum is positive, because it's positive, then we can keep it, and then we keep it and add a number to it. If it's not worth keeping, then our current running sum should be the number. And each time we'll use a global maximum sum to keep track of the global maximum. So if the global maximum sum is less than the current running sum, the global maximum sum should be the current running sum. And that's it. That's all the code. And then finally we return the global maximum sum. Let's evaluate. So we submit. It's pending, judging, and accepted with 576 milliseconds. Pretty good. Now we analyze for complexity. So since we only iterate through the nums array once, here's a time complexity O(n) and a space complexity O(1). Thank you very much for watching.